Okay, I think we are ready to start. Although we have a very small number of people in the audience, but still we can get started. And we have more on Zoom and more, hopefully, on the live stream. So it is my pleasure to welcome Professor Bożena Wieczorek, and I hope I'm pronouncing the name correctly, from the Silesian University of Technology in Gliwice, Poland. I have to say that the Silesian University of Technology is a partner university in our European University Alliance, EURECA-PRO, and it is a pleasure to host Professor Wieczorek with us this week. So we're going to listen to her talk. A few words about Professor Wieczorek. She's an assistant professor with the Department of Algorithmics and Software in the Faculty of Automatic Control, Electronics and Computer Science. She earned her PhD degree from the Silesian University of Technology, if I'm not mistaken, and her academic interests focus on algorithmics and parallel programming. She's also very engaged in exploring the use of modern technologies in programming education, and I believe the talk we're going to listen about today is very related exactly to this topic. So the title is Coding, Cognition, and Kinect, Educating with Technologies. So thank you once again for being here, and we're looking forward to listening to your talk. Thank you very much.
Thank you.
Let's share now your slides first before you start. Now we need to do some screen sharing from Zoom so that the remote audience can see your slides.
Okay. Yes. Okay.
All right, let's get started.
Okay, thank you. Good afternoon. It's a pleasure to be here. You know everything about me, so I think I can move on to my presentation. In my presentation, I would like to cover two topics. The first one is connected with programming education, and the second one is related to my research and my article I wrote with my colleague. But before we start, just a few words about university and about Gliwice. So Technical University of Silesia is located in Upper Silesia. As you can see, it is southern part of Poland. It used to be very region with lots of coal mines and steel works, very industrial one. But it has changed. Actually, now it is a center of new technologies with lots of IT businesses, IT companies. Okay. Here you can see just a picture of our market square. It is winter, I can see. In the middle, there is a town hall. It was built in 18th century. On the next picture, you can see the fountain, Neptune Fountain. It's a very popular place for meetings with people. Another picture, here you can see our Piast Castle. Actually, it's not a castle. It is called like that because, I don't know, maybe for tourists. It is a part of fortifications. It was built in 13th century and by Piast dynasty. And this dynasty ruled our country from 10th century to 14th century. And last picture, it's actually the building where I work. So the Faculty of Automatic Control, Electronics and Computer Science, quite modern one. But we have also older buildings at our campus from the beginning of 20th century. We have nice dormitories, so just you're welcome to come and see our campus in Gliwice. All right, so that's it. Now we can move on to more serious stuff. Teaching programming can be a little bit challenging. I usually have very diverse students group. I have students very novice to programming, beginners, and I have students quite experienced in programming. So what to do to keep them engaged during the whole laboratory? Another challenge is how to evaluate their programs. When you give students quite complicated task to do, and you have to evaluate it, it's really hard work. It's tedious and prone to errors. So you cannot be sure that you are objective, yes, assessing those programs. So I thought maybe it is a good idea to use automated assessment systems because they can do my job. So actually you can find different online judge systems in the internet. For example, Code Forces. It's for free for everybody. But I actually use Polish platform, and I will be talking about it just in a minute. When you use these online judge systems, you don't have to check codes manually, because it is checked automatically against prepared test cases. That's one thing. Students get immediate feedback and they know the score. They can just work on these platforms also at home. When they are interested in algorithms, for example, they can just find different tasks to develop in this area. So they can work anywhere, anytime, in their own pace. In Poland, we have a Szkopu platform. It was actually developed for preparing competitions, algorithmic competitions. So there are hundreds of different algorithmic tasks that's ready to use. Teachers can also prepare their own tasks. What you should do is just give the description of the task, prepare test cases and correct answers for each test, and then give some limitations to time, to memory, and score for each test. And that's it. Szkopu, so our platform, as I said, it was used for preparing and organizing algorithmic competitions. Actually, Polish teams, Polish students are very good at it. So in International Olympiad in Informatics, we won over 130 medals, including 44 gold ones. Only Chinese students are better. So we are really good at it, and students just use this platform to prepare for those Olympiads. The national one and the international one. There's also Baltic Olympiad in informatics. So it's very useful for them. As you can see on the slide at the bottom, there's a ranking. So students can see how their programs work, if they work or no, and they can compare with each other. Here you can see the names of the students. Here are the tasks and scores for each task. You can see there are lots of 100 points, some zeros, and some 20s and others. So how does Szkopu work? Students just implement program according to the task. In C++, they can also use Java and Python language if they want. So they submit their code. The code is compiled and is tested over several test cases. And they get feedback if, the test is okay for this test program works. You can see it. Maybe I can enlarge it if it is possible. Let me check. Okay. Here you can see the feedback. So you can see for the first test, it was okay. So you score 12 points. The next one, you got wrong answer. So you have to work on it. And then we have timeout. So your program is too slow. And then memory limit overflow. So you use just too much of your memory. So the students get the feedback and they can work on their programs to submit better solutions. All right, so the score is from 0 to 100. It's based on the test cases. Okay, all right. I use this platform, this online judge system, automated assessment system, during laboratories for first-year students. So I teach programming, and I usually prepare 2 contests, one for beginners and the other for more advanced students. So the beginners have easier tasks, and the more advanced student, more challenging ones. They just work on the task during class. If this is not an assessment, they can just finish it at home, or they can find any other task on the platform if they're interested in developing their skills. Okay, I also use this platform, but it's not obligatory for the students during my algorithms and data structure classes. So I usually prepare or look for tasks which are related to topics I cover during the class. And I usually try to find tasks that are connected with real-world problems, so that students can see where they can apply this particular algorithm. I think it is good for them. All right. In order to know if the students like to work with this platform or no, I conducted a survey. So I asked a few questions. I asked, what is your experience in programming? How you feel while working with the platform? What do you like? What do you dislike? And what can be improved? And I got answers. And just first, what students like. Most of the students just like very much this quick feedback and objective evaluation. More advanced students pointed out that when they solve quite hard task, they feel satisfied with it. And they feel motivated to do even more, to move up in ranking. So they like this competitive element in this platform. What students dislike? I think it's okay. What students dislike? Mostly beginners and novice to programming complained that the feedback is not enough. If there is something wrong, they don't have 100 points. If there is something wrong for a particular test or lots of tests. They just don't know what to do, where to find the error. So they feel frustrated with it. Most of the students mentioned that maybe it would be better to have an access to test cases so that they can check particular test, run the program for the particular test and check what is wrong. And this lack of guidance, the most important thing that just dislike about working with an online judge system. Okay, in my experience, I think that this is a really helpful tool which can be used in our courses. First of all, it reduces our workload, enables students to work at home and develop their skills. But the platform in its current form cannot replace the teacher. But in the future, if the platform will incorporate artificial intelligence and the feedback will be much more like a guidance for the students, I think the platform can teach independently. And then I will have to retire because I will have no work. Okay. Well, there is something I think with, okay, maybe this way. Okay, I know what to do. Okay. All right, so now the second topic, connected with the article I wrote with Jacek Szedel, my colleague from the Department of Algorithmics and Computer and Software. The article's title is Estimating Ego States, the Machine Learning Perspective. So in this project, we want to make an intersection between artificial intelligence and psychology. More precisely, we want to just use machine learning techniques to estimate ego states, which are defined in transactional analysis. Just a few words about this transactional analysis. So it is psychological theory and method of therapy developed by Eric Berne. The main idea is that our personality is structured in 3 distinct ego states: parent, adult, and child. They just interact with each other. We shift between those ego states. What does it mean that our personality is in parent state? When we are in parent state, we are very controlling, critical. We think you should, you must, it is not allowed. We can also be very caring and supportive. And we are usually in this, unconsciously, of course, in this state when we are stressed or when we are taking care of others, people, yes? Okay, adult state. Adult state is very rational, logical, solves problems based on facts and reasons. So it's actually crucial state for our personality because it helps us to solve problems, to develop, and actually the transactional analysis, the main goal of this is to make it stronger in our personality, because it also helps us to have a good relations with people. Okay, child state. child has all the emotions. So child is spontaneous, creative, playful, joyful, but can also be feel guilt and anxiety. So our goal is to develop a software in which we will just estimate ego states the person is at the moment using skeletal data from Kinect sensor. But before we can do that, we have to just, train the machine learning algorithms, the machine learning models. So we have to collect data, label them, and prepare data sets for the algorithms. And that is what we are doing at the moment. Okay. All right. So there are lots of articles because body language is very important in this transactional analysis. So there are lots of articles in which we can find information. How can we recognize the states, ego states, according to our gesture, posture, our tone of our voice. So, for example, adult is usually shown as a person with a person pointing finger, with firm tone and upright posture. Adult is quite neutral with rational movements of his body. Child is usually playful and exaggerated expressions we can find in a child. So we just need some behavioral indicators to label our data. So we want to know which gestures, postures we can connect with the particular state, ego state. There is also a concept that for therapists, it is good to think about parent, adult, and child state in the context of time. So how it is in the past, at present, and in the future. And actually, we adopted this model. So we label our data, annotate our data with 9 labels: parent, adult, and child in the past, at present, and in the future. So 9 labels according to this concept. Okay, here you can see the structure of our software. So we have Microsoft Kinect sensor. We have web camera. So actually what we collect is video and audio streams, which are synchronized with skeleton movements from Microsoft Kinect. This information goes to our main module. Here we can go through all the frames. We usually record 5 frames per second. So we can go through all the frames, look for key ones, so that we can just label them. After that, we can visualize the results. All the information we gather from those sources is kept in a database system. How to collect data? We actually started by asking 15 students of our university to describe projects they are working on recently. So the students first, at the beginning of the recording, they just were describing the project, and then they were asked questions. You can see some of them just at the bottom, because we would like to, have the information from the past, in the future, at present. So we asked some questions to gather, to collect the data. Okay, so what are the results? We actually have two visualizations. One is connected with one participant, with one individual. So we actually, you can see actually at the bottom left corner, you can see frame clouds. It means that we layered frames one over another for one particular student to see, the intensity of his movements, how they behave, and they behaved very differently. You can see on this picture students who was really frightened, shy, and nervous, and he confirmed it after the experiment. In the middle, there's a student with, I would say, normal behavior. He was calm and had rational movements and calm dynamics. And the third one, it was the students with very dynamic movements, with this animated manner of speaking. And you can see it, yes, on this picture. So here we just checked the students' behavior, the intensity of their movements. The second visualization is connected with ego states. And what you can see here, okay, I will try to enlarge it. No. Okay. What you can see here, there is no parent state detected. Why? Because it was a conversation between a professor and a student. So there is just no way to, to achieve parent state. So now we see that we have to do another experiment, just in less formal environment, so that we can just gather data also for this ego state. Adult state was dominant, which is actually good. So you can see this adult in the future, at present, and in the past, and all together. There were also frames labeled as child. So child in the future, at present, and in the past, and all together. So it was the second visualization. It's the best. Okay, it's the next one. All right, so we believe that this tool, this software, can be very useful in education. For example, we can use it for training teachers to see if they have the balance between an adult state and child state. Because they have to be enthusiastic, yes, but also clarify the explanations. We can also use this software when it can be also used for teachers who, for example, prepare video lectures or podcasts. They can just, it can help them to prepare, to create more engaging ones. It can be also used analyzing the communication between teacher and students in a classroom. Because our software is expandable, so we can also put one module which will read text messages. And you can also estimate ego states in texts. So we can go through emails, let's say emails, chats, and forum posts, and try to find those ego states also there. Okay, I think that's it. Thank you for your time and attention. I hope it was a little bit interesting for you. Thank you. If you have any questions, okay, I can just...
Well, thank you very much, Professor Wieczorek, for this very interesting talk. I think we have time, plenty of time for questions. Feel free to ask for the microphone so that the remote people can also listen to you. Yorgo? Okay, let me get the microphone to you.
Thanks for a very interesting talk. I'm not sure I got how can you differentiate between the ego states, like adult, child?
Okay. We read a lot of articles about it. Yes, how to recognize those ego states in our posture, gesture, and tone of our voice. But I think it's not enough. So we are thinking about also gathering data from facial movements and, for example, skeletal movements of seated person. So maybe altogether it will give us more proper data sets. It's not easy, yes. It just preliminary results, and we are still working on it, trying to maybe to gather more information, more streaming channels to be sure that we can recognize those ego states more precisely, yes, for those data sets. It's not easy. Yes, it's not easy.
There is bibliography in the psychology. There is psychology biography on how, like, the posture.
Yes, we are
connects to those ego states. So these ego states, like those three ones, they are a standard thing in the literature, or is it you coined them? Is like your approach?
Theory, yes, it's a psychological theory,
okay.
And actually, we have parent, adult, and a child, but we can also divide the child into a free child and adopted child, and a parent to caring parent and critical parent. So they're just
a long literature on that.
Yes,
I guess.
But it is precisely, very structured and precise in this transactional analysis. That is why we just use this theory to connect it with artificial intelligence, because you need to have something which is quite precise, yes, and structured to to use machine learning. You have to know precisely.
I'm not sure like psychology and preciseness go together, but precision.
Yes, I can understand.
Whatever.
Yes.
Can I ask a follow-up question? So, and I also didn't get. So you were talking about like past, present, and future, like state. So, but then, so I'm not entirely sure I got what you meant. So, assuming that the current state is child. Why can't the future state be parent, or like the past state be adult? Because it seems like in your examples that the past, present, and future states coincided.
All right. So, for example, we ask student a question: will you be taking part in the project in the future? Yes. Or what can you do with the knowledge you acquire during this project future? So we asked questions about the future and about the past, and they just answered them. This concept of this present, past, and future actually it's more connected with therapy methods. So the therapist can see the progress of the patient, yes, how it was in the past, and how it will be in the future. It's just something which therapists use while in the time they meet their patients, the people they want to help. But we thought that maybe it will be used for those therapists, so we just use this model. Maybe it will be helpful for them.
Can you have transitions from like adult to child to parent? Because you had like this matrix, but that implied that, you know, if you are a parent now, you used to be a parent and you will be a parent. But
no,
it will change.
we are usually not in one state all the time. Yes?
Yeah.
No, because it's impossible. So the states just interact with each other. We shift from one to another. So let's say, I don't know, when I am at home and I have kids, sometimes I might be in parent state, yes, because I take care of them, so I am caring, supportive. And then I go to work, so I can't be in a parent state. I have to be in adult state.
Yeah, I get it. So,
Okay.
but you seem to imply, say, because you were showing these examples, you seem to imply, but maybe I didn't get it, that, you know, you go from parent to parent to parent, but that's not the case in your slides.
No,
Okay.
no.
No worries, thanks.
No,
Okay.
no.
And about the other topic, so do your students these days used to?
The other topic, we have a question on the same topic. Just answer this question. So I think Civitar Amenti, you feel free to turn on your microphone and ask actually live. I can read it. Is there the incentive to find hidden characteristics of the eco states using machine learning? So can we answer this question maybe before we move to the first part?
To find hidden characteristics of the ego state.
I think the question is if there is any motivation to find hidden characteristics of the ego
What do you mean,
states.
hidden characteristics?
Maybe you can elaborate on your question. Feel free to turn on your microphone and speak.
Can you hear me now?
Yeah, we can hear you.
Yes, my question is if we, you have the incentive to, besides the characteristics that you have found in the literature that you talked about with for the previous question, if you want to also find hidden characteristics using the data that you get from the kinetics.
What do you mean hidden characteristic?
Hidden. Things that are not shown, are not so visible, they're hidden, covered.
The not in the literature, things that only the machine with the camera that can
Things that are not in the literature, but maybe discovered through the camera.
All right, but you know, you have to know how to classify those I don't know, gesture or posture or something which might be hidden. So I'm not sure actually how to do that, because we focus on this behavioral indicators. Yes, so we just know what can we connect with a particular state. But I don't know, we will see how it goes, because we haven't started incorporating artificial intelligence. So this
just to help a little bit, it seems that with new technologies, when you have a camera, you have a Kinect, you can capture a lot of information from a person, like motion and maybe repeated gestures and things like that. So I think the question refers to possibly new features or new characteristics that might be discovered using these new technologies that were not known before. In that sense, they're hidden.
Okay.
And so they can actually enhance the existing literature, maybe.
Oh,
I hope I'm interpreting the question correctly. I see a
possible,
comment that this is exactly okay. Thank you.
It is possible, I think. Yes, it is possible. But because our results, this was just one experiment, so we have to do a little more, and we will see how it works. So it is possible, I think.
Thank you very much.
Thank you.
Okay, so Yorgos, if you don't mind, I can ask also something on the second part. Let's finish on that part and then move to the first. I was wondering why you focused only on this particular, you probably mentioned that, but I missed it. Why did you focus only on this particular three ego states, like parent, adult, and child?
Because there are only three general states.
In general, okay.
Yes, in this theory. In this
theory. And I was wondering, okay, to continue my question, I was wondering with a camera and a Kinect, the first thing I would use to differentiate between a child and the other states is, the size. Was that part of your work, or you probably consider children that are quite tall, let's say, and they cannot be differentiated by height or size?
No, we didn't consider the height of the participant because we are also very often in a child, ego state. When we are spontaneous, creative, when we ask questions, when we are curious, when we are cheerful, playful, we are in child ego state. So it doesn't matter. Your age doesn't matter.
Okay, we can all be children, okay?
Yes.
So if I understand correctly, the idea is to figure out the state, the internal state, and not necessarily what is going on in real life.
No, it's just your personality. Yeah?
I see. So the same person can be an adult, and then a parent, and then a child.
When you are, let's say, a young dad, you just play with your kids, yes? So you do something, and you are for sure in this child ego state.
Yeah. Okay, good. So thank you. We can go back to the first part.
Yeah, I was wondering if, in your experience, since LLMs have arrived, do the students engage more with the existing platform or with LLMs? And also, what's the view on this? So, yeah, a possible extension would be to add LLM in this automated this tool that assists grading. However, I'm a bit skeptical. So, for instance, right now, LLMs have emerged that so actually products have now emerged that promise to do this all the way from beginning to the end. Like the teacher wouldn't have to even open the the assignment. And I'm wondering if this is a good idea. And as you said, yeah, then we all have to retire, which I'm not sure that's a good idea either. So thank you. So your views on that? Actually, given the wages of retiring in Greece, it's not a good idea. If the wages were higher, we would.
Okay, thank you.
So any comment on that?
Was it the question? Sorry?
Yeah, well, if I understand correctly, yours, the question is,
like the platform money as much as they used to, or do they prefer just ChatGPT or whatever? And having LLMs
okay.
to this?
Okay. I think there's a problem now while teaching programming, because when you give students very simple tasks, they can just use ChatGPT and it will solve it. So what I do during my laboratories, I just prepare those contests on the platform, and they just do it on their own. Yes, and I help the beginners. I help them when it is not an assessment, because you can also assess using this platform. You can also assess students when it's just normal laboratory. So I just help the beginners, and usually those more experienced students just can solve tasks on their own. For me, it is less work, because I don't have to check all the the codes. I can still help people, help students, and when I do an assessment using this platform, it just very easy, because I have the scores after finishing the contest. And I think that the platform is more suitable for more experienced students, because they feel more confident and they go for more tasks at home. For the beginners, they sometimes complain because they fight with those errors, bugs, and they just have no guidance what to improve. But I am still there, yes, at the laboratory, so I can just tell them, you have to look at this line, think about it, if it is correct or not. I think just incorporating a bit of artificial intelligence would improve the platform, because they can just be given better feedback. And maybe there's access to those test cases would be also a good idea, but I can change the software. It is somewhere in Warsaw, because we use this for our national Olympiad in informatics, the platform. I think it is a good idea, and I also prepare students for algorithmic competitions, and it is for them, for my scientific circle, it's just the best thing ever, because there are hundreds of tasks and big archive of algorithmic tasks, so they can just train, implementing hard programs.
So if I understand correctly, if you combine this automated grading, let's say, of programming assignments with feedback provided by some kind of AI or LLM model, then we're without job then in a few years, right?
I can't still...
You can also have an avatar making movements. So then you can replace the teacher all the way. Possibly, yeah.
I think it's the future, unfortunately.
So, are there any more questions? And I think we have a few more people on Zoom. I forgot to ask earlier if we have any remote questions. We already had one. So here's your last chance, last call for questions. I think there are no more questions, so we can wrap it up at this point. So thank you for talking about this very interesting topic, actually two topics, okay? One on using new technologies for teaching programming, and the second on recognizing the ego states. And thank you so much for coming here to the Technical University of Crete. we hope to see you once again, or maybe visit you in Gliwice, Poland.
yeah.
Okay.
You are invited. Thank you.
All right. Thank you very much. Let's thank this.